And let's just dive right in. We're looking at symmetry. And so, guys, the idea behind symmetry is that I could draw a line down the middle of a figure. Let me pop this figure open here. I could draw a line down the middle of the figure, and I could fold that figure in half over that line. And it would match up perfectly. You like my dancing dots? No? I'm going to turn those off. All right. And it would fold over perfectly. So, the line of symmetry, the definition for that is a line through a figure that can be folded into two equal reflected parts. Thank you. So, lines of symmetry. Here's one line of symmetry there. That's an ugly line of symmetry. I'm going to erase that little guy and then try to do it a little better. Boom. Okay, that's a little better. So I could fold those two halves over each other, and then I would have the equal parts, or the parts would match up. Now, another line of symmetry. I could go from this corner, right, to that one. That would be another line of symmetry. What about from the midpoint of this line, from this guy right here? That's another line of symmetry here. Any other lines of symmetry that you see? That was 3, that was 2, and that was one line of symmetry. All right. Let's look at the square. I've got this line of symmetry, that line of symmetry, this line of symmetry, that line of symmetry. If I folded that figure over any of those lines, those two halves would match up perfectly. So, how many lines of symmetry do I have? 4. 1, 2, 3, 4. Alright, I want you guys to try the pentagon and tell me how many lines of symmetry you can find in that pentagon. I'll give you about 20 seconds. Nick? What's that? There are as many lines as vertices. That's right. I've got 1, 2, 3, 4, 5 vertices over here. So that's 1. This is 2. Here's another one. 3. 4, and I'm going to have to come up with, let's say brown. 5. Very good. So here's what I suggest when you guys are doing this. I want you to do the one here as well. And here's what I suggest is do it either, if you have them, do it in like different color highlighters or pens or pencils, like I'm doing here. But if you don't have different color highlighters or pens, then do like one solid line, do one dash, dot, dash, dot, dash, and then another type. Maybe it's just dots. But that way you can really tell the difference between those. Oh, Nick, we only have 3 lines here, but we have 1, 2, 3, 4, 5, 6 vertices. You can do it in the middle. Very good. So I can go, that's a 4th line. That's a 5th line. And that's a 6th line. So Nick's postulate rings true if I have a regular, and remember it only works with the regular polygon. Then I could say lines of symmetry equal number of either vertices or number of sides. With a regular polygon, my lines of symmetry equal the number of vertices or the number of sides. Vertices and sides should be the same thing. If you have a pentagon, you're going to have 5 vertices, 5 sides. Okay. Example 1, tell whether each figure has a line of symmetry. If so, draw all the lines of symmetry. Okay. Abby, for A, how many lines of symmetry have you found so far? Okay. Excellent. And that is perfect. 2 lines of symmetry. 1, and I'm guessing that the other line of symmetry, Abby, was right down the middle here? 2. Okay. Okay. From the diagonals is an excellent question. Thank you. And that's something, I'm glad you actually asked that, because that's a way that a lot of folks get one of these guys wrong. If I take this, and you can do this with your patty paper too, if you so desire, and then I flip it, then along my diagonal here, well, actually, it looks like it is. Here, I shouldn't have flipped it. But it's actually not along the diagonal. Hold on. I'm trying to figure out my little guy. Oh, there it is. So this is the top image reflected along that diagonal. And so you can see that if I folded that piece in half, and you could do this with your patty paper too, if I folded that piece in half, then you wouldn't have a line of symmetry. You'd have an arrow. Okay. How about for figure B? Anybody want to take a guess? Yes. You are correct. Very good. That's it. 1 line. And then, did anybody get this yet? See? Yeah, Scott? 4. Well, we've got this one, but Skylar, do I have any others? No, so it's just 2, right? 2 lines of symmetry. Because if I did it along the diagonal, then I would have my little arrow again.
Wait, why is arrow bad?
Because a line of symmetry is you must be able to fold that figure along that line and get the exact same figure. So if I took my patty paper and I traced the figure, and then I drew that line and then fold it, those two figures would be exactly the same. Excellent, excellent question. Everybody should be thanking Jake for saving some points on the quiz. So, yeah, that's if I folded this top figure along this line of symmetry, well, not line of symmetry, it would actually bring up this. So it's just 2. Okay? All right, so we have line symmetry. Net symmetry over line. Now we're going to talk about a different kind of symmetry. And I'm going to make a big deal about how different this is because a lot of people get these two confused. They think we're talking about the same thing, but these are actually different. Okay, rotational symmetry, different type of symmetry. Rotational symmetry is when a rotated figure is exactly the same as the pre-image. And then in example 2, take out your patty paper just in a corner, and I want you to trace out that K, that saw blade there. Okay? And then I want you to rotate it from its original point to the next point where everything lines up. And so, how many points of rotational symmetry do you think this guy has? 1, 2, 3. You got it. 12. Because it has 12 spikes. And then, a little bit more difficult question. The angle of rotational symmetry is the amount of degrees you have to move your figure to line it up again. So, how would we find out how many degrees we would have to move this figure if there are 12 spikes? Boom. All right. So Jake's postulate says that all you have to do is divide 360 by number of spikes, or vertices, And that gives you your angle of rotational symmetry. So this 360 divided by 12 is 30 degrees, yep. So we know that this is 30 degrees in here. Okay, and then finally, tell whether each figure has rotational symmetry, and if so, give the angle of rotational symmetry. So, for example number 3, we're going to use Jake's postulate, and I want you guys to put your patty paper on the star, and then I want you to trace out that star. And rotate it. And then using the number of spikes, then I want you to figure out what the angle of rotational symmetry is in A. And once you're done with that, do B. And once you're done with that, do C. And once you're done with that, do your homework. Okay, Sarah, what did we get for the degrees, the angle of rotational symmetry for A? 72 is perfect. 72 degrees. Excuse me. So all we did was we divided, let me put that up there, 360 by the number of spikes, which was 5, and that's how we got 72 degrees, using Jake's postulate. All right. Excuse me. It doesn't quite work with this one. You just have to be careful with B. Yeah, Will? You got it. 180. Well done. Will avoided the trap there. He saw that there were 4 spikes, but he said, I think if I rotated this guy, I don't think it's going to match up. So that would be our 90 degrees. Obviously that does not work. That is 180. And if I actually rotated it around the right thing, it would completely match up. So it's just 1 rotation and 2 rotations. So with this, if it doesn't look like the number of spikes work, number of rotations. We had 2 rotations, so we divided 360 by 2. That was 180 degrees. Nicely done, Will. And last but not least, we've got our little green lantern symbol here, whatever that is. And does anybody want to venture a guess? Any brave soul? 1 degree. Not 1 degree. 90. We've got 1 rotation, 2 rotations, 3 rotations, and then back to its original 4 rotations. 360 divided by 4 rotations equals 90 degrees. And that's it. Notice there is no back to these notes.